Example 2 is a really typical type of question for applications in Trig, in that it's got to do with tides and the depth of water, whether it's got to do with fishing or boats being able to come in or out of bays and things like that. So it's a very typical type of application, so important to sort of understand. This one here talks about the height of water in metres at the end of the jetty at Ciocco's resort. Is given by this sine function, and you're told that t is in hours, so it's important to take note of the units, and particularly after midnight on a Saturday night. Part A again is a straightforward question. It's asking you for that maximum or minimum. So as we did in example 1, you could do it through the graph, or this is quite simple in the sense that we know that the maximum and minimum is either going to be 8 plus 3 times 1, which is 11, or 8 plus 3 times negative 1, which gives you the 5. So you're going to range from 11 down to 5. Please make sure that you actually tell the examiner, if this was a question in the exam paper, that your maximum is equal to 11 metres and your minimum is equal to 5 metres. Then we need to, in part B, sketch the graph. Like we did in example 1, I would suggest or recommend that you define your function in your calculator. So menu, actions, define, type it in quickly. So h of t, but remember, replace the t with an x. H of x is equal to 8 plus 3 sine pi x over 7, and done. Then to graph it, insert a graph page and just type in here h of x, and again you can see that it's a little bit out of the window. You could just drag that down and across like that, or you could go into your window settings, and we know that it says something about the first 48 hours, so 0, and then this bit here becomes 48, and there's your graph between 0 and 48. You would have to label key points. So this point here, you should know just by working out the fact that there's been that vertical translation. You're adding 8 to the rule, so that should be 8 in terms of your center line would go across here at 8. So this point here would get labeled as 0, 8. And then your maximum we know is 11, your minimum you know is 5. But when does that occur? Part C in the question is actually asking you at what times will there be high tide on Sunday. Now remember, the T units you were given were hours after midnight on a Saturday. So these first two high tides are your high tides for Sunday. So that's what you need to be finding. So the first one happens at 3.4999, so in other words 3.5 hours, and the second one happens at 17.499 hours. So when you're answering that question, please be really careful that you're not going to be writing in here 3.5 hours. The question's asking you at what time. So it's not 3.5 a.m., it's 3:30 a.m. in the morning. And then the other answer was 17.5, which is 5:30 p.m. So you do need to make your answers address the units of the question. Part D, what is the depth of water at midnight on Sunday night? So because we've actually defined the function, it's easy to just hop into your calculator page and say, okay, midnight Sunday is the same as 24 hours. So all you're working out is h of 24 is 5.075. So your answer there would be 5.08 meters. And again, in the exam, the question would actually ask you for a certain number of decimal places. Then we go on to the fact that Tiffany has discovered that there is an ideal time for fishing, and that's when the depth of the water is more than 9.5 metres. At what time on Monday, so again, read all parts of the question, should she drop a line in? So we're looking at what time is it on Monday that we get a depth of 9.5 metres. So again, on our calculator page, I'd go to the graph, I'd actually type in the line 9.5 metres. So what I'm looking for is Monday. So this is Sunday up to here, and this is Monday. But if I wasn't too sure, let's say I thought it was this point here, and I found that point, so intersection over here. Looking at the time, you can see that it says 19.83. So obviously to get to Monday you need to be past 24 hours, so that's not the one. We need to find this one over here. So intersection point, there it is there. So we're looking for 29.167 hours after midnight on Saturday. So you need to be working out what time on Monday is that. So on your calculator page, you could say 29.167 minus the 24 hours of the Sunday before brings me to 5.167. So at 5 a.m. on the Monday morning. But what do you do with this decimal part of the answer? It's asking you for a time. So, you know, logically, you don't say to someone, I'll meet you at 5.167 in the morning. You actually say it's 5 o'clock and then however many minutes past that. So that 0.167, you need to, 167, you need to times that by 60 because there's 60 minutes in an hour. And you can see there that it's 10 minutes. So your answer here would have to be at 5:10 in the morning on Monday. That's when she needs to drop her line in. And then that's only half the answer, because when you look at the graph, this is Monday, and so she can fish over here all this time here, but then this is still Monday as well. So what time can she actually go back and put her fishing line back into the water? So if we find this intersection point of 43.167, then the same thing, we can go to our calculator page and say, well, 43.167 minus the 24 hours of the day before is 19.167. So what time on the Monday is that? Well, we know it's going to be 7 o'clock at night, and the 0.167, like we did before, we know is 10 minutes. So your answer there would be at 7:10 p.m. as well. For how long will the water be at this ideal depth? So looking at the graph, what that's asking you to answer is this section over here. How long is she going to be fishing at an ideal depth? So we need to find this other intersection point over here. Which is the 33.83. And then we work out the difference between these two answers here, and that would be the length of time between that intersection point and the other intersection point. So what you're just doing is 33.83 minus 29.17 So 33.83 minus 29.17, which is 4.66 hours. But again, we don't answer it as 4.66. If that's what you write, then you're not going to get the full answer. You need to be working out, well, what is 0.66 in terms of minutes? So times it by 60, and that's 39.6 minutes. So 40 minutes. So it would be 4 hours and 40 minutes is the length of time that she would be at her ideal fishing depth of water, and hopefully catching lots of fish. The last part of the question, at what time on Monday night should she return to drop a line in? I actually answered that back up here. That's the 7:10, which is when you look at the graph, this was the Monday morning, and then she could go back later on Monday night and drop the line in again, because she's again at that ideal depth of water. So that's example 2. Hopefully that makes sense, and you're ready for example 3. Well done.